So we'll start with our daily summary at the top of page 45. In this lesson, we make extensive use of the slope-intercept form of a line, and we'll also see the point slope form of a line. This is a reminder. Oh, no, this is not a reminder. This is the first time we're seeing this. So here's an important note. We are skipping sections 2.1, 2.2, and 2.3 in the textbook. You are not responsible for them. However, there is notation and a vocabulary word introduced in those sections, which you will see in your MyMathLab homework. And it will be quite confusing if you have not paid attention to this note. The textbook, those sections cover something called functions that isn't part of our curriculum. If you take Math 107 next semester, you will see functions. From this point forward, if you see the word function in your textbook, you will mentally replace that word with the word equation. You see function, it becomes equation. If you see symbols like this, F parentheses X, or G parentheses X, or H parentheses X, anything like that, some letter parentheses X, you will mentally replace all of those symbols with the single letter Y. So for example, if you read, consider the function F parentheses X equals 3X minus 2, we change function to what word? Equation. Go ahead and cross this off on your notes right now just to make sure that you are clear. This is page 45. Yeah, right in there. And then F parentheses X, all of that gets crossed off and changed to what letter? Y. So we translate that funny looking sentence with some unusual word and symbols in it to consider the equation Y equals 3X minus 2, which is a lot friendlier looking from our perspective. Any questions on that? Again, you're going to see the symbols and you're going to see the word function in MyMathLab homework. I have no control over that. All I can do is remind you, you are changing the word function and you are changing those symbols. Amy?
In algebra,
yes. No, the F parentheses X, it still means Y. So, yeah, they're equal. Yeah. Exactly. And there are reasons for wanting to play around with functions and to use that notation instead of the letter Y, but that doesn't help us this semester. Next semester, it'll help. So I'm not lying to you. Like F of X, changing it to Y is exactly, it's fine. It's totally fine. Yeah. Well, I don't want us to get confused because I'm not going to talk about what F parentheses X means. If anybody wants to know what it means, see me after class. We can talk about it. It's not complicated, but it's not part of our course. Yeah. Okay, so number one, slope-intercept form of a line. Your favorite equation maybe from your past math class. For a linear equation of the form y equals mx plus b, what does the m stand for? Slope. Somebody else, what does the b stand for? Is the y-intercept. So we've seen maybe in a previous math class y equals mx plus b.
So that's the slope-intercept equation, correct?
Yeah, we'll call it slope-intercept form.
To put it on your reference sheet if you need it. That's
yes,
formula.
Exactly. Right, so that's a formula you could put on your reference sheet, although this particular concept is not going to be on the coming quest, right? None of this new stuff. Okay, so I think that's all good. In our previous lesson, we saw a car depreciation problem where the car was originally worth $10,000 and depreciated at a rate of $500 per year. Do you remember this problem? Started with $10,000 and depreciated at $500 per year. And then there was an exercise that said write down an equation for the value of the car after X years. And so I think a lot of people wrote this. They said, okay, well, it starts at $10,000. What's the next symbol going to be to take care of the fact that we're depreciating or losing value? 500 minus 500x, right? That 500x takes care of 500 every year, right? If you increase x by 1, you take away another 500. And if we write that formula in a different way, this guy right here, if we just shuffle the terms around, put that positive 10,000 at the end and the minus 500x in the beginning, then all of a sudden, we've got something that looks just like our y equals mx plus b, right? What is the m in that equation? is the negative 500. The m, the slope, is always the number touching the x. And in fact, in that problem, you calculated the slope to be negative 500, and then that y-intercept is 10,000, and there was a graph, and you plotted a y-intercept at 10,000, or maybe the graph was given. Okay, first example you're going to do right now. Write an equation in slope-intercept form. That's the one we just saw. So named because it involves the slope m and the y-intercept b. Write an equation in that form of the line that has slope m equals negative 2/5 and y-intercept 0, 3. Go ahead and fill it in. So you are changing the m to negative 2/5. You are changing the b to the single number positive 3. So y equals negative 2/5 x plus 3. Really easy when you know how to do it. If you see this on the quest, well, not this coming quest, but a future one, easiest question you can find as long as you know how to do it. So I'm not trying to diminish, like you got to make sure you understand exactly what that y equals mx plus b formula means. Any questions on that one? Teresa?
Y equals -2/5x plus 3.
Perfect. Number 3. Let's find an equation of the line that passes through the points -1, 4 and 2, -5 by following the process outlined below. So this is going to be a much tougher problem than the one that we just finished. We have 2 points. You can plot them if you want to. Honestly, it's not really going to help us to plot these 2 points, but would you believe that wherever these 2 points are, there is a single straight line that goes through them both? And that single straight line has some equation. And our job is to find the equation of that single straight line. So for example, maybe the equation of that line we're about to find is this one in purple, y equals negative 2/5 x plus 3. That's going to be the final answer. So the final answer is not x equals 2. The final answer is an equation of a line, something like purple. All right, so I have written down a very detailed step-by-step process. We're just going to read along kind of quickly here to find the equation of a line given some information. Now, many of you already know all of the steps to this process. And so if you can do this more efficiently than what I've written here, no problem. As long as you get it right, that's all that I care about, okay? But I just wanted to write something out so that everybody had a method that they could follow that would be guaranteed to work. So we're just going to kind of sweep everybody up regardless of what your past experience is with finding equations of lines. Okay, step A says circle both coordinates of a point on the line. If you have 2 given points, pick either point and circle its coordinates. We have 2 points given to us, yes? You pick either one, it doesn't make any difference. I have chosen -1, 4, it is written right there, okay? Either one. Write down the slope of the line. Now finding the slope is its own process. In fact, we just finished the section on slope. So you might have to do a calculation like this formula that we saw last class and then earlier today. We haven't seen the word perpendicular. I think it's coming next class or the one after. But perpendicular slopes have a relationship. Parallel lines have a certain slope relationship. We'll see that. But anyway, write down the slope, whatever that means. So in this case, slope of the line connecting these 2 points, I could do 4 minus -5. And then downstairs, what do I have to do? -1 minus 2, right? Just be consistent. So there it is right here. 4 minus -5 over -1 minus 2. So we do the calculation and we get the slope is -3. Good? That's old. Then it says write y equals mx plus b. This is me just really trying to be detail oriented. I don't need you to do this step. But if you are not getting these right 100% of the time, then just follow my lead even if there's some extra stuff written out. So we just write y equals mx plus b. Then we replace the m with the slope that we just found, but we write everything else in the equation. So the only thing that's going to change is that this m is about to become what number? -3. And that's all that I've done differently there. But I have written everything else out, including the plus b. I think this is an important step. Again, it's not mandatory, but I think for some folks having trouble finding that b, this is an important step. Okay, let's see. So we got that. All right, and then it says put a star next to that equation. There's the star. We're going to refer to that equation later on, so I just need a way to reference it. Okay, part E. Rewrite the equation from the previous step. That's the y equals -3x plus b. But replace the x and the y in that equation, x and y, with the coordinates of the point that we circled way back when in step A. What were the coordinates that we circled? -1, 4. So what we're going to do is change the x to -1 and the y to 4. And that's exactly what happens here. X became -1, y became 4. Everything else got copied, yes? And this is an equation with only one unknown in it. It is b, and that's what we're about to find. So we're going to solve that equation for b. I think that's what it says down there in part F. So in this case, -3 times -1, that's just +3. So how much is b? Is 1. Okay, and then here's this last step. It says plug the value that we just found for b equals 1, into the equation with the star. That was why we started, so we could reference it right now. So we copy that entire thing, y equals negative 3x plus b, but we changed the b to the number we just found, which was a plus 1. This is our final answer, y equals negative 3x plus 1. So the reason that I'm so detail-oriented on this process, when it seems like we just kind of wrote a lot of extra stuff that maybe we didn't need to, is that it's actually kind of a tricky process. Y equals mx plus b. How many letters are in that equation? There are 4 letters in that equation. Yes? Y, x, m, and b. The first thing we do is find a value for m, and then we change that m into the number. It was, what, negative 3? Yeah, negative 3 in this case. And then that negative 3 stays the rest of the problem. But we keep the b exactly like it is, and then we change the x and the y into numbers, right? We change the x to negative 1 and the y to 4. And then that allowed us to find b, and then we figured out b was 1, but then what happened to these numbers, that 4 and that negative 1? What did they become? They became x and y again. So it's kind of confusing because some of the letters just get replaced with numbers and you stop, but then other letters get replaced with numbers, but then they go back to their original self. And so that's why I have all these details here, is that we just got to be really careful how we treat the x and the y and the m and the b, because they don't all kind of behave the same way. Okay, on the next page, let's run through number 4 here. It says we can also find the equation of a line using a different method. Suppose a line has slope m and contains the point x1, y1. Those subscripts are just supposed to indicate that we have an x and we have a y and they're particular numbers, but you don't need to get lost in the fact that there are 1s there, it could be 2s there, it doesn't matter. So here's a brand new equation of a line. I'll highlight this guy. Y minus y1 equals m times x minus x1. And that guy right there is called the point slope form of a line. So let's see how we use it. Number 5, find an equation of the line that passes through these 2 points. These are exactly the same 2 points we just did. So the final answer here had better be the same as the y equals negative 3x plus 1 that we got a minute ago. Let's make sure. Okay, so here's the process. This one will not take us as long. It says find the slope of the line. We did it already. The slope is still negative 3. It says rewrite the equation, but change the m into the slope that we just found. So the only change here is that the m becomes negative 3. Everything else is copied just as it is, yeah? And then we're going to change the x1 and the y1 to the coordinates of either point. It makes no difference which point we choose, but we circled negative 1, 4 before, so let's just circle it again, and I'll write down up above, this is your x1 and this is your y1. So the x1 is the number negative 1, and the y1 is the number 4. And we just change x1 to negative 1 and y1 to 4, right? Everything else copied. And this is really where things get tricky, because in the other problem, we change the x and the y into negative 1 and 4. But in this problem, the x and the y stay x and y the entire time, and it's x1 and y1 that get changed to numbers. Okay, and then here it's fairly straightforward. The goal is to just solve the equation for y, so we can distribute that negative 3. Well, I guess first change the minus minus to a plus. Everybody good with that? That's right down there. Right, minus minus becomes plus. And then we can distribute that negative 3 through here, so we get negative 3x minus 3. And then again, the goal is to solve for y, so how do we move that minus 4? Just add 4 to both sides, and we get y equals negative 3x plus 1. Same exact equation. Okay, which one is better? I don't know. It's 6 of one, half a dozen of the other. I think that both processes take about the same amount of time, about the same amount of steps. In my teaching career, I have seen, so when I was a student, this was before electricity, I think we primarily used this equation, the y minus y1 equation. But in my teaching career, I've seen the shift from focusing on that equation to actually more focusing on the mx plus b. So I'm just going to ask you to pick the one that you feel more comfortable with. Your choices are this y minus y1 and the mx plus b. Everybody's going to raise their hand for one of these. Raise your hand if you're more comfortable with this one, y minus y1. Looks like 3, 4-ish, maybe 5. Raise your hand if you prefer the y equals mx plus b. It's a lot more. And I've seen this shift happen. So something happened at some point to high school math where there was this kind of transition. So the fact is, I don't care which one you are good at. I'm not going to force you to use one over the other. I just want you to pick one and be really good at it. Okay? That said, in the My Math Lab homework, I'm pretty sure that there are a couple of questions where we'll force you to use one or the other. You can do that. It's not like under the stress of a testing environment. So, just have this in front of you and you can follow the process and get the problem right. But honestly, I don't care how you do it. Just pick one and get really good at it as opposed to being kind of okay at both. Okay, so I think that is that. The activity starts on the next page. We have, what do we have? 45 minutes. See how far you can get in the activity. Raise a flag if I can help.